30. We're going to do a little mini lecture here of algebra review. First thing we're going to look at is a function. If you recall, the definition of a function is the output is the function of the input. The output is the function of the input. So remember, after you see these words of comes the input. Okay, let's give an example. If we have f of x equals 2x plus 3, is this right here the output or the input? The x is the input. The output is f of x. That's the output. So we put a value into x, and then we get something after we do some math to it. That's our output. So here's an example. We're going to say, let g of x equal x squared. We're going to evaluate. For letter A, if we have g of negative 2, and we're supposed to evaluate that, what we do is we put the negative 2 into our x value and evaluate. So for the x, I'm going to put a parentheses so that I don't mistake this negative. It must go inside the parentheses. So that equals 4. If I didn't put it in parentheses, we would have negative 2 squared, but that is negative 4. Because according to PEMDAS, we square first and then attach our negative. So it's very important when you have variables and negative numbers, you use your parenthesis. So I'm going to take this away. Okay. Now, if we did this with a letter, g of a squared, we'll go ahead and put it in there. We're going to put a squared into our x, and then we're going to square it, and that becomes a to the 4th. All right, another one, C. We have g of the 4th root of a. G of the 4th root of a. So we're going to square that. Again, I put that in parentheses. And we get the 4th root of a. Okay. Now remember, the 4th root, what does that mean? It really means we're looking at a to a fractional power where the root is the denominator in the fraction. So we have a to 1/4 squared. And if you remember what we do with a power to a power, we multiply. So that gives us a to 2/4, which is a to 1/2, which equals square root of a. Can you see that in there? Yeah. Okay, so now what we're going to do is one more problem for this. I'm going to do letter D. We're still working with g of x equals x squared. Okay, and letter D is g of x plus h minus g of x all over h. Okay, so how do we start with this? Well, g of x plus h, that becomes our input right into this equation. So we're going to have x plus h squared to start with. G of x plus h, we put an x plus h in there, and we get x plus h squared. Minus g of x. G of x is x squared all over h. Now h is some new variable. You saw a little bit in the video that you watched ahead of time. And if you didn't watch that, that means that you're in a different class. This class that I'm teaching right now is strictly online. We're in fall 20. Okay, so how do we handle this right here? We're going to go ahead and FOIL this, right? Oops, minus x squared over h. Okay, so foiling that, we have x squared plus 2xh plus h squared minus x squared all over h. Okay, so what cancels? This x squared and this x squared cancel. All right. Now, I see H, H, and H. So I'm going to factor out an H so that I can cancel it. Factoring out an H here, we have 2x. 2x times H is 2xh plus another H. H times H is H squared. All right, so now the H's cancel, and our answer is 2x plus H. All right, very good. Now we're going to look at a piecewise function. Just a reminder of what a piecewise function is. Okay, so piecewise function. Okay, that's when we have something where we break the function into pieces. All right, and we break it into pieces based on the domain, which is our x values. So I'm going to say if x does not equal 4, then we're going to use the equation 2 plus x. Now, if x equals 4, then we're going to use 3 as our answer. So now let's evaluate this. If I evaluate f of 0, where is 0 not 4 or 4? 0 is not 4, so we're going to put it right in here. 2 plus 0 equals 2. Now let's look at f of 4. We ask ourselves, is 4 not 4? That's silly, right? It's 4, so we say it's 3. F of 4 is 3. Okay, so let's do f of 5. F of 5, of course, is not 4, so we're going to put 5 in there. 2 plus 5 equals 7. All right. How do we graph a piecewise function? All right. We're going to graph one. I'm going to put a little graph over here to the side. And I'm going to go over 3, up 3, to the left 3, just for your notes. You don't have to go very far. 3, 3, negative 3, negative 3. Okay? All right, so here's our piecewise function. F of x equals, and we're going to split this into 3 pieces. We have for x less than 0 is going to be just x. For x equal to 0, we're going to have 2. And for x greater than 0, we're going to have x plus 1. So how would we graph this? Well, let's pick some values. We're going to pick some values less than 0, equal to 0, and greater than 0. Okay? I always like to start with 0. If we put a 0, what is our answer going to be? The answer is 2. So I'm going to put a point at 0, 2, right there. Okay? All right, so let's look at some negative values. If x is less than 0, which it is, negative 1, then f of x is just x, negative 1. So negative 1 is going to go right here, okay? And then a negative 2. Negative 2 is less than 0, so we're going to write negative 2. Negative 2, negative 2. Okay. All right. Now how about negative 1/2? Negative 1/2. If I put negative 1/2, I'm still going to get negative 1/2, right? All right, so where is this going to go? We said if it's 0, it goes to 3. But anything less than 0 is going in this straight line. So at 0, 3, I'm going to put this straight line with an open hole to not include the origin and make an arrow this way. All right? So that is the equation of this line for all values less than x. So we keep this an open hole because when x equals 0, it shoots up to 2. Okay, so let's do positive numbers now. If I put in a 1, 1's greater than 1. Oh, 1's greater than 1? No, it's not. What are we going to do? Well, let's look at a 2. Is 2 greater than 1? So we put in there 2 plus 1 is 3. Okay, so let's put, that's about as we're going to go, is 2 plus 1 is 3. Now, since it must be greater than 1, and 1 doesn't work, we're going to look at 2, 3. 2, 3 is a point. Okay. It can't equal 1, so at 0, we're not going to have anything, but greater than 1. So we're going to go to 1, put an open hole here, and go up this way. Okay, so we have no values between 0 and 1. There's no values. For x greater than 1, when we get to 1, we have to put a 0 where it would go. Actually, we would be adding 1. So at 1, we would add 1. It would look more like this. Sorry about that. If we added 1, we would get 2. So that's a 0 there. And then 2, 3 is here. There we go. Okay. So now how do you get this open point right here if you were to figure this out on your own? Since it can't equal 1, let's put in a 1 and we get 2. So at 1, 2, we leave an open hole. And the next one was 2, so we put a 2 in there and got 3. So 2, 3. And so we know the rest are going to go this way. Okay, very good. I'm going to take a break and we'll come right back. This is part A and we'll do part B.